Hello, it's Mr. Strom again, and I am back with the anatomy lesson walkthrough, and we're on section 3.3, and we're going to talk about articulations. Articulations. So what are we talking about? Well, articulations, we're talking about joints. Joints articulate, try to put those two words together in your mind. And that joint is when two bones meet. And really the primary function of articulations or joints is to allow movement between bones. However, the structure of some joints does not enable movement. So there are two classifications. We'll deal with functional and structural, and we'll break those down further. The functional classification is determined by how much the bones are able to move. Structural classification is determined by how the bones connect to each other. There are two main considerations: whether there is a joint cavity or not, and what kind of supportive connective tissue surrounds the joint. So within the functional classes, there are three. We call them Synarthrotic joints, Amphiarthrotic joints, and Diarthrotic joints. So Synarthrotic joints are immovable joints. So for example, the sutures that connect the bones of your skull are synarthrotic joints. Sutures on the skull, see how they're together, bone to bone. But you don't move those around on your own. They don't move. Then we have Amphiarthrotic joints. They are slightly movable. So whereas synarthrotic joints are not movable, these are kind of movable. And an example of these joints would be the disc between the vertebrae of your spine. That forms an Amphiarthrotic joint. Diarthrotic joints are freely movable joints. So they're classified in how much they can move. And the hip joint is a good example of that. And these are the joints you're more familiar with each and every day. So you can move your arms, your legs at the hip joint, elbow joint. And then you have your spine, which it moves, but not quite as freely as these. And then your skull is always, it's not moving. Hopefully your skull doesn't move around. But those three were functional classes of joints. Then we have structural classes. And we break those down into three classes as well: fibrous, cartilaginous, and synovial. The fibrous joints are characterized by the absence of a joint cavity. So there is no joint cavity here. And there's a presence of fibrous connective tissue surrounding the articulating bones. So think of the skull and the sutures again. The cartilaginous joints are characterized by the absence of a joint cavity. So there's no joint cavity here either. And there's cartilage binding the articulating bones together. So here we had fibrous connective tissue, and here we have cartilage. An example here would be the pubis symphysis. That is a cartilaginous joint. Then we have synovial joints. They're characterized by the presence of a joint cavity. So this is the one that has a joint cavity. And there are ligaments that provide support for the articulating bones. And a ligament is just connective tissue that connects a bone to another bone. So the classes actually mostly correspond to one another. Most joints, fibrous joints, are synarthrotic joints. So the ones that have fibrous connective tissue between them are generally joints that can't move. Most cartilaginous joints are amphiarthrotic joints. So if there's cartilage between the joints, it more or less is likely to be able to move a little bit. And then you have synovial joints. Those are the most movable, and they have ligaments in between those joints. So diarthrotic, they can move. Amphiarthrotic, kind of move. Synarthrotic can't move. Articulations. Now, within the fibrous joint class, there are 3 types. And they are synarthrotic because they are very tightly woven together by that fibrous tissue. And that makes the joints rigid, hard, and you can't move them. They're immovable. And the 3 types are sutures, syndesmoses, and Gomphoses. Gomphoses. The sutures, like the bones of the skull, like in the bones of the skull, they bind the skull together. The bones don't fuse together until around 18 months or 2 years old in a baby human. Then in early adulthood, the fibrous connective tissue is replaced by bone. Then you have the syndesmoses, and these are fibrous joints found in your forearms and your legs. In the forearms, the syndesmoses joint is between the distal end of the radius and the ulna, whereas in the leg, this joint is between the distal end of the tibia and the fibula. And this synarthrotic joint allows slight movement when these joints are rotated, but not in every case. Then you have Gomphoses, and those are fibrous joints between the teeth and the supporting bones of the jaw or the mandible. The Gomphoses is located where the root of the tooth is attached to the periodontal ligament within the socket of the jawbones. So we had 3 types of fibrous joints. Now we have 2 types of cartilaginous joints. These are semi-movable joints, and they can move when you're twisting or compressing. There are 2 types, the symphyses and the synchondroses. The symphyses are cartilaginous joints where the articulating bones are separated by a pad of fibrocartilage. Examples of symphyses joints are the symphysis pubis and the intervertebral joints. And then there are synchondroses, and these are cartilaginous joints where the articulating bones have hyaline cartilage in between them. And an example of this type of joint are some of the bones of the skull and the joint between the ribs and your sternum. Another example would be the epiphyseal plates between the diaphysis and the epiphysis of growing bones. The epiphyseal plates are temporary, but then with time they will solidify and become bone. At this point, the synchondrosis no longer exists. Synovial joints are diarthrotic joints because they are freely movable, and we'll talk about that more in the next section. Articulations or joints are where two or more bones meet. We are now summarizing everything. And there are two ways to classify joints. And then within those two classifications, you have three classes. So we have functional classification, synarthrotic, they are not movable, amphiarthrotic, slightly movable, diarthrotic, freely movable. And then you have structural classification, and within that we have fibrous joints, cartilaginous joints, and synovial joints. And remember that these classes correspond to one another. Things that are not movable tend to have no joint cavity, and the fibrous connective tissue is why they don't move very much. And then amphiarthrotic, they have cartilage, and that allows them to move a little more than those joints. And then diarthrotic joints, synovial joints, they have a joint cavity and ligaments, and that allows them to move a little more easily compared to the other joints. And that is the end of that section. I'll open up the other one so we can get going. But this next section, we're going to go into further detail about synovial joints, because those are pretty interesting joints. Joints are where two bones meet, and their main function is allowing bones to move, the movement between bones. Synovial joints, there are two types of classifications for joints overall. And synovial joints are is a structural class. All right, so here are the three functional classes. Here are the three functional, and three structural. And synovial falls under the structural classes. And those are the ones with the joint cavity and ligaments providing support for the articulating bones. So if you can look at this picture, this is your elbow joint. And you notice that there's a cavity, a hole. And there are ligaments holding this joint together. And these types of joints, synovial joints, carry out smooth movements while also providing stability, strength, and rigidity sometimes. Oops. There is a wide variety of joint mobility among all different people. Most often, this is the result of body conditioning. The range of motion also varies according to the specific joint. The factors that determine the synovial joint's range of motion include the structure and shape of the articulating bones, the strength and tautness of the specific ligaments, tendons, and joint capsule, the size, arrangement, and action of the muscles that span the joint. A synovial joint is composed of a variety of structures, namely joint capsule, articular cartilage, ligaments, menisci, and bursi. The joint capsule is a fibroelastic cavity that encloses two articulating bones. The joint capsule is filled with a fluid called synovial fluid, and this fluid helps to lubricate the joints. With all that moving, you don't want the joint to become damaged through all the movement. This lubrication helps with that. And the articular cartilage is found at the ends of the articulating bones. So we have this joint capsule, and then within that, you have the fluid and the articular cartilage at the ends of the bone. And this provides a smooth surface and exchanges waste products and nutrients with the surrounding fluid in here. A ligament is connective tissue that connects a bone to another bone. They provide support to the articulating bones as well as span the joint. They may either be within the joint capsule or on the outside of the capsule. Interior view of the right knee is on your left-hand side. And then we'll look at that for to get a good visual. The menisci are tough, fibrous cartilaginous pads found in the joint capsule of some synovial joints. And it has two purposes: to guide the articulating bones and to cushion the contact between the articulating bones. Right there. And then we have the bursi. They are flattened pouch-like sacs that are filled with synovial fluid. They're located between muscles or where a tendon passes over a bone. A tendon sheath is a type of bursa that wraps around and lubricates the tendons of certain muscles, especially those that cross the wrist and ankle joints. There are 6 types of synovial joints. They're classified by their structure and the kinds of movements they permit. The 6 types of synovial joints are gliding, hinge, pivot, condyloid, saddle, and ball and socket. Gliding joints permit side-to-side and back and forth movement. Along with some slight rotational movement. Examples of gliding joints include intercarpal joints and intertarsal joints. So within your wrist and ankle, near your hands and feet, you see these gliding joints. And then the sternoclavicular joint as well. A hinge joint permits bending in only one direction. So think of a door. Most doors can only open one way. And in this type of joint, one bone is always concave and the other is convex. So think of your knee joint. You can bend your knee backwards, but you can't bend your foot the other way around. That would be not a good thing. The humero-ulnar articulation of elbows and the joints between phalanges. Then you have pivot joints, and these permit rotation about a central axis. And in this type of joint, one bone is rounded and fits into a depression or hole in the other bone. So some examples of pivot joints are the proximal articulation between the radius and the ulna. This allows you to turn a doorknob. Articulation between the atlas and axis. This allows you to rotate your head. Condyloid joints permit an up and down motion and side to side motion, but they can't rotate. In this type of joint, the end of one bone is oval or convex and fits into an elliptical or concave depression of the other bone. And some examples of that are radiocarpal joints at the wrist and the joint between the metacarpals and phalanges in your arms or your hands. Then we have the saddle joints that permits a wide range of movement. In this type of joint, we have one bone being concave and the other convex. And it gets the saddle joint name because one of the bones is shaped like a saddle and the other is shaped like a rider sitting on the saddle. So picture a saddle and then another bone conforming to that shape. And an example of that would be between the carpals and the first metacarpal bone. That is a good example of a saddle joint. And this type of joint allows your thumb to cross the palm of your hand. So touch your index finger to your thumb, and then if you touch your thumb to your pinky finger, you can see how your thumb crosses your palm. Then we have ball and socket joints. Think of your hips and your shoulders. They have the greatest range of movement in your body. And the end of one bone is rounded, so like a ball, and the other bone is convex and creates a cup-like cavity. So think of a ball going into a socket, ball and socket, ball and socket. Makes sense. So to review the two primary functions of synovial joints, you can carry out smooth movements with these, and these joints give you stability, strength, and sometimes it can be rigid when they need to be. And in order to do these primary functions, a synovial joint is composed of a variety of unique structures, namely a joint capsule, articular cartilage, ligaments, menisci, and bursi. Here we get another diagram of everything. And we talked about the 6 types of synovial joints. These are joints in your body that give you the most movement: gliding, hinge, pivot, condyloid, saddle, and ball and socket. All right, so that's the end of the first 2 sections of 3.3. I will get back and finish up the 3.3 later, but until then, have a great day. I hope the rest of your week goes well, and yeah. All right, I'll see you guys later.